In this activity, we're going to be looking at different vector-derived forms of the line, and we're going to start out with the vector form of the line. So here I have what I call my position vector, u. We're going to start out with our position vector, u. This vector is going to determine where our line starts. It's always positioned with its tail at the origin. In this case, u is 1, 2. The second vector is a direction vector, and this is actually my direction vector over here. And I can move it all around, that's fine. Here's my parameter s, and I can change my parameter. Finally, added to the position vector u is the direction vector times a parameter, s times v. And so this just looks like a regular linear combination of two vectors where I only have one parameter. Now as I change this parameter, what you'll see is I can create a line. All the points that I can achieve with this particular linear combination makes a line. And if I want to look at this line, I can see that it has a slope of -3. It's got a rise of -3 for a run of 1, and it has an intercept of 5. And so with this vector equation of the line, I've produced the exact equivalent of the y equals mx b form of the line, y equals -3x plus 5. So to work on the first part of this activity, I've included a link to this Geogebra file. Now I know that it's not working for all of you. You can easily substitute simply drawing the vectors on a piece of grid paper to make this work. But you're being asked to find the equivalent y equals mx plus b form of a line given a position vector and a direction vector. When you're using Geogebra, here's your menu bar. If you want to select something, you need to choose this arrow. So if I had a position vector of 4, 1, and I had a direction vector of -3, 1, this is the change that I would make to make that happen. And there we go, it should snap. Anyways, now I can adjust my parameter, and I can use that to figure out exactly what equivalent form of the line that is. And once again, if this doesn't work for you, and I know it's a great big file, it'll take a while to download, you can always do this with a piece of graph paper.